This is 3.5a notes, measures of position. Okay, so we've done measures of central tendencies, or the middles. We've done measures of dispersion, or how spread out. Now we're doing measures of position. So we're going to talk about how to think about where data points are located within a data set. Okay, and we're going to talk about it in a couple different ways. Today, we're going to talk about percentiles and quartiles. Next time, we're going to talk about z-scores and the normal distribution. Okay. So we're looking at where things are located. So first we have percentiles. When we have a percentile, it separates the ranked data. Okay, so make sure you realize that for both quartiles and percentiles, we're talking about ranked. It's got to go low to high. Okay, and we're going to look, it's separated into 100 equal sections, and every data set has 99 percentiles. Okay, if you ever heard of, like, from a state test or the SBAC testing or something, you said, well, you're in the 95th percentile, you're in the 74th percentile, those things. Okay, this is what it's talking about. And if you didn't know, the highest you can go is the 99th percentile. Okay, we'll talk about why. So basically, if I separated my data, so we'll look at a little number line. Okay, separate my data into equal pieces. I'm going to use ... because I don't want to draw this whole stupid thing, because there'd be 99 little pieces I have to separate it into. Okay, so trying to be as even as possible there. So I would start with my lowest number. Okay, that's the bottom end. And I'm going to end with my highest number. That's the top end. Okay, and in between are going to be my percentile values. So we call this percentile 1, percentile 2, percentile 3, percentile 4, percentile 5, and so on until we get to percentile 97, percentile 98, and percentile 99. Okay, and if you actually saw this all written out, you would notice that how we separate percentiles is we break up 1% of the data. 1% of the data is in between every single percentile and between the lowest and highest number. Okay, and if you added all of those up, all the little 1%s, you would get exactly 100%. 100% of the data means all the data. Okay, so if you use 99 percentiles, you separate into 1% sections, and those 1% are where we get percentiles from. Okay, we're also going to look at quartiles, and they relate actually directly to percentiles. We'll talk about how in just a second. Once again, you need this data to be ranked. We're going to have 4 equal sections, quartile quarters, 4 sections, and every data set has 3 quartiles. Okay, so pay attention to this. A lot of people get confused as to why we only have 99 percentiles, not 100 percentiles. But if you understand the quartiles, you relate that directly to percentiles and you'll understand. So if we have the lowest number here, the highest number here, and we separate into 4 equal sections. So I'm going to kind of break this up. And you can see if I use 3 lines, I've created 4 sections. In this case, it's a quarter in every section. And so you can actually see that you use 1 less value to break it up into that many sections. So 3 values here broke it up into 4 sections. So this is quartile 1, quartile 2, and quartile 3, with 25% of the data within each section. The words quartile might sound familiar from previous math classes. Quartile 1 is the exact same as the 25th percentile. right? If you mapped it out to the 25th percentile, you would have 25% between the low and that value for both of these, okay? Quartile 2 is the 50th percentile, the exact same as the 50th percentile, which is also the exact same as the median, okay? So we're actually going to find a new way to find the median. This will be the third way you've learned across your math history to find a median. You can count in, that's number one. We learned the depth formula, that's number 2 way. Now we're going to use percentiles or quartiles, that's the third way. And they all give you the same value, okay? And the third quartile is the same as the 75th percentile. Okay, this distinction is important because our formula we use right here, that capital P represents percentile. Okay, which percentile are we dealing with? So if they're asking you to find Q1, you have to understand that that is the 25th percentile. If they're asking you to find Q3, you have to understand that's the 75th percentile. If they're asking you to find the median, you have to understand that is the 50th percentile, because you need to know which percentile to use this equation. Okay, I'm going to write a whole bunch right here, and these are very, very important. Okay, so we have our formula. The depth, that's what the lowercase d stands for, the depth of the percentile, so it's a new depth formula. The depth of the percentile is n times k divided by 100, where n represents your number of data points, k represents what percentile are you looking for. Okay, and when you do that, you get a number. And you have two options. First, if the nk over 100, that is the value you get out of that formula, has a decimal. If it has a decimal, it does not matter what decimal. If it's a 0.001 or a 0.9999, it doesn't matter. If it has a decimal, go up to next whole number. For depth. Okay, that means if I use this formula and I got 9.1, that means I get the 10th number. I go up to the next whole number. If I got 9.8, I use the 10th, the next whole number, okay? If, so the second option is if nk over 100, basically it does not have a decimal or is a whole number. No decimal. If it does not end up having a decimal, add 0.5 for depth. Okay, so that means if I use this formula and I get exactly 10, I get the 10.5th value. Okay, so that'd be halfway between the 10th and the 11th term. Okay, so this is something that you're going to want to make sure you understand. You need to know how to use this, how to get to these values, and how to use your two statements. And you should always be using exactly one of them. You don't use both of them every time. You look at the scenario. Do I have a decimal? Go up to the next whole number for depth. Do I have a whole number? Add 0.5 for depth. Okay, you're going to use exactly one of them every time. All right, so first of all, remember, you always, no matter what, have to have ranked data. So I need to rank this first. So 42, 56, 62, 65, 72, 78, 81, 87, 90, and 93. Don't forget that step. Just like a median, you got to get it in order first. Okay, next, we want to find Q3. Remember, we need the percentile. So quartile 3 is the 75th percentile. That's important. So I need n, number of data points, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I need k, 75. And then I'm going to use my formula. Depth of Q3, because that's what it's asking for, is 10 times 75 divided by 100. Okay. So in this case, I get 7.5. But remember, that's not done. We have to use one of these two things. If it has a decimal, which it does, go up to the next whole number for depth. So I have the 8th term. That is my Q3. 1, 2, 3, 4, 5, 6, 7, 8. Okay, in Math 3, you may have been taught, you probably were taught to count for the quartiles. Don't do that in this class. Okay, do not count. Both of these are an estimate of the different percentiles and quartiles, and they can end up different. So do not count for quartiles. It only works for medians in this class, okay? So be careful about that. Next, we have percentile 20. So we're using the same data set, so I still have n equals 10, because there's still 10 numbers. This time, my k is 20. So the depth of the 20th percentile is 10 times 20 divided by 100, which is 2. But we always have to use one of our rules. If it's a whole number, add 0.5 for depth. So 2.5th term. So that is halfway between the second and third term. So my second term is 56. My third term is 62. So we do that. So I get the 20th percentile, add them up, divide by 2, and I get 59. That is my 20th percentile for this data set. Find the median. Okay, remember that the median, or the second quartile, is the 50th percentile. We always need the type of percentile. So once again, I still have 10 data points. Remember, it depends on the problem. Don't assume it's always 10. That's a mistake people make all the time. We need the 50th percentile. So the depth of the median is 10 times 50 divided by 100, which is 5. In this case, it's halfway, so it's a whole number, so 5.5, halfway between the 5th and 6th term. 1, 2, 3, 4, 5, 6, 72 and 78. It's halfway between 72 and 78. So my median, halfway between those two, I get 75. Okay, Q1, that is the 25th percentile. So n happens to be 10, because that's how many data points. K is 25. The depth of the 25th percentile is n times k divided by 100. So it's 2.5, which we have to follow our rule. Since it's a decimal, next whole number is the third. So I get the third number. 1, 2, 3, 62 is my Q1. Okay. Also my 25th percentile. They represent the same thing. So let's do a couple more. Find the 90th percentile. So n is 10, still using that same data set. K is 90 now, so the depth of the 90th percentile is 10 times 90 divided by 100. That is 9. We have to follow one of those rules. So the 9.5th term. That means it is halfway between 90, which is my 9th, and my 10th, which is 93. So 90 plus 93 divided by 2, that is the 90th percentile. I end up with 91.5, halfway between 90 and 93. And finally, my 30th percentile, n equals 10, k equals 30. So the depth of the 30th percentile is 10 times 30 divided by 100, which in this case is 3. Have to follow those rules, so that's a whole number. That means 3.5. Halfway between the third and fourth term, so halfway between 62 and 65. So that is 63.5. That's my 30th percentile. I'm going to say this one more time before we move on to the next thing. Remember, n is not always 10. N represents how many data points. In this case, we had 10 data points. Make sure you count how many for n. Okay, the next thing is the mid-quartile. It is halfway between the first and third quartiles. It is not the second quartile. Okay, the second quartile and the mid-quartile are two different things. So my mid-quartile is halfway between the first and third. So I have to know my first quartile and my third quartile. I add them up, divide by 2. If you don't know them yet, you have to find both of them, then add them up, divide by 2. Okay, so find the mid-quartile from example 1. So we actually found the first and third. The third quartile was 87. The first quartile was 62. So my mid-quartile is those two added up. So 62 plus 87 divided by 2, which is 74.5. Which, remember, your second quartile is your median. My median was 75. My mid-quartile, 74.5. Those are different. So do not confuse your second quartile and your mid-quartile. Two separate things. Okay? Next, or I guess really last, we're going to talk about the 5-number summary and the box and whisker plot. Okay? So the 5-number summary, we have obviously 5 numbers. So I'll tell you what numbers you're going to use for your 5-number summary. You always use the lowest, the quartile 1, the median, which remember that is quartile 2, and quartile 3. I'll actually erase that and just leave it the median, and then the highest. Okay, so really you use the lowest, the highest, and the quartiles to create your 5-number summary. Your box and whisker plot, be careful. Make sure you have some sort of scale to use. You get to make your scale most of the time. I think on the test, we'll probably make the scale for you. But if there's no scale, you'll need to make the scale. So notice my scale is counting by 2s. And then your box and whisker plot, you start with your low number. That's a point. Then you have your Q1, your median, your Q3, and your highest number. Okay. And you put a box in between Q1 and Q3. You put an extra line in the box at your median. And then the whiskers are the ones that connect the outside points. And you always label. Okay, you would normally label with numbers, but in this, where we don't have any numbers yet, so we're just going to label with what the values would be. So low, Q1, median, Q3, high, box between Q1 and Q3, line at the median, connect the dots with the whiskers for low and high. Okay, so we have an example here. If you wanted to, you could go through all of the steps to find all the pieces. I'm going to just give you them. So the lowest number is 21, right there, the lowest number. Q1, if you actually calculated it, which is the 25th percentile, you would get 31. The median, which is the 50th percentile, you would get 36.5. Q3 which is the 75th percentile, you get 42.5, and the highest number is 50. So usually this question actually takes a while, okay? Because you actually have to find all of those values. So you have three things to find. So the low and the high is given. What is the lowest number? What is the highest number? You have to find your three quartiles, Q1, the median, and Q3, separately. Then you create a scale. So this time I'm going to count by fives. Okay, how I choose my scale is I actually look at my numbers and I kind of think I need to get from 21 to 50 with not too many values. What's the easiest way to do that without making it too small? So I count by fives. It's easy numbers to deal with. Okay, so then I need to plot my points. So 21, that's really close to the 20. 31, that's really close to the 30. 36.5, that's really close to the 35. 42.5, that's halfway between 40 and 45. And then 50 is where it ends. Okay, so box between Q1 and Q3, extra line at our median, connect the dots, and always label 21, 31, 36.5, 42.5, and 50. Okay, and there we go. Box and whisker plot. If you know how to find the quartiles, very easy. Just make sure there's a scale. Okay, keep it to scale. That is an important thing. All right, I'll let you do your 3-sentence summary for measures of position, including 5-number summary and box and whisker plot.